Good morning to all. So today class we are going to see the VSEPR theory. The full form of VSEPR theory is valency shell electron pair repulsion theory. So this theory, why they have proposed that Lewis structure basically will give information about outermost electrons. Right here you can see the outermost electrons. But this theory, Lewis theory, it could not explain the shape of the given covalent molecule. So to explain the shape of the given covalent molecule, the scientists Sidgwick and Powell who proposed the VSEPR theory. In this theory, we will study total 4 postulates. So we'll see one by one. The first postulate is describes about a shape of a molecule. It gives the shape of the molecule is completely depends upon the number of valency shell electron pairs around the central atom. So basically any molecule, if you see, the shape is determined by the number of valency shell electron pairs, whether it could be bond pair or lone pair. How many electron pairs are there? That number will decide the shape of the molecule. So as we know, the number of valency shell electron pairs, it will completely depending upon the group number. So majority of the elements, if you observe, so for example here BeCl2, it is consisting 2 bond pairs. The BeCl2 2 bond pairs. So here these 2 bond pairs I am representing like this, and it is having a 0 lone pair. So first we will count for H2O molecule. Oxygen is having 6 valency electrons. Out of 6 valency electrons, 2 are involved in the bond pairs. Remaining 4 will be in the form of lone pairs. So 2 lone pairs, and it is having 2 bond pairs. So the first postulate is giving information about how many number of bond pair electrons and how many number of lone pair electrons are present in the central atom. Second postulate, once you know the lone pairs and bond pairs, then that bond pairs and lone pairs always tend to occupy in such a position in a space that should minimize the repulsions and maximize the distance. So we know that the electrons are having similarly charged. So being similarly charged, the bond pair and lone pair electrons are always get repelled each other. So due to these repulsions, these bond pair electrons are always tries to accommodate themselves as far as apart is possible. So that's why these 3 bond pairs are tries to locate with a 120-degree bond angle. Whereas in the case of CO2, these 2 bond pairs are also having similarly charged. So these 2 bond pairs are also trying to locate as far as apart, so with a maximum distance, so it can minimize the repulsions. This is about second postulate. So in the second postulate, you will get a clear idea about how the arrangement will be there in the bond pairs and lone pairs. Why CO2 is a linear, why not L shape or like that? Okay, because in the linear, this is the only possibility where you can accommodate these 2 bond pairs with a maximum distance. Third postulate of VSEPR theory, if you see, if the central atom of a molecule is surrounded only with a bond pair electrons, then the geometry is said to be regular geometry. For example, here I am considering the molecule is CO2 or BeCl2. In this case, the BeCl2, the beryllium is having only 2 bond pairs. It doesn't have any lone pairs. So if the molecule doesn't have any lone pairs, the geometry is said to be regular geometry. Like here you can say BF3, and here you can say CH4 methane and PCl5 and SF6. Whatever molecule if you take, if the molecule do not have any lone pairs, if it consists only bond pairs, then the geometry will be regular. When the central atom of a molecule is surrounded by both bond pair and as well as lone pair, then the molecule do not have a regular shape. It is called as distorted shape. So what is a distorted shape? For example, you see here, this is the molecule NH3 we all know, and this is H2O. If you count the total number of valency shell electron pairs, both are having similar valency electron pairs. In the case of NH3, it is consisting total 5 electrons, so it is having 3 bond pairs and 1 lone pair. So total 4 valency shell electron pairs. Whereas here also 2 bond pairs and 2 lone pairs. Total 4 valency shell electron pairs. Both are having similar valency shell electron pairs. But still the geometry can be same, but the structure is different. Why? Because there is a difference in the number of lone pairs. So if at all the molecule is having different number of lone pairs and bond pairs, the structure will vary. The reason here is, you can see here, the lone pair generally used to occupy more space. It can move around with a faster rate, and can occupy more space rather than bond pair. Because bond pair is localized and it will occupy a less space and it can't move around. So that was the reason here. Here it is having how many lone pairs? 2 lone pairs. Here it is having 1 lone pair. Generally, as it occupies more space, so it can repel at the maximum extent. So if you compare the repulsions between the lone pair, that will usually it will be greater than lone pair and bond pair repulsions. So that was the reason when we draw the structure of any molecule, the lone pair will be arranged in such a way to minimize the repulsions with a maximum distance. And here when we compare, the distance between lone pair will be greater than corresponding bond pair distance. So in this case, here you can see both compounds are having equal number of electron pairs, but the geometry is same, but the structure is what? The structure is, one is pyramidal and another is bent shape. So these are both are said to be as a distorted structures. Why distorted? Because instead of bond pairs, it also consisting a lone pairs. So that's what the fourth postulate. Here you see, when the central atom in a molecule is surrounded by both bond pairs and lone pairs, then the shape is called as distorted shape. So these are all said to be an example for distorted molecules. Fourth postulate, you can see the relation between the geometry and the number of electron pairs around the central atom. We could see here in the case of polyatomic molecules, some molecules used to have double bond, whereas some molecules used to have a single bond. And the force of repulsions, when we compare, the multiple bond repulsions will be very high when compared to the multiple bond single bond and single bond repulsions. So, and also according to the VSEPR theory, all bonds are treated as a single bond. See here, if it is bond pair, so whether it is double bond, triple bond, whatever it is, we need to consider that is a bond pair. So here it is consisting 2 bond pairs. This is also consisting 2 bond pairs. Both are 2 bond pairs. So it is said to be both are having a similar geometry, that is linear geometry with same bond angle 180 degree. So that's the result. Here you can see the bond angle also will become as a same. So these are the total 4 postulates of VSEPR theory. So in the next class, we will discuss how to predict the geometry by considering the VSEPR theory postulates. Thanks for attending the class.